These are the 6.1 and 6.2 notes. This is page 6. And so we are going to take a look at transformations in terms of our exponentials. And again, a little funky because it's not quite as obvious how these are getting moved sometimes. We're going to take a look at the anchor points. So the 0, 1 are where our y-intercept would be. And then the point that results when x equals 1. So here, 1, 3 kind of tells us what the base is. So A, p of x equals negative 3 of x. Remember, when we take our y value and make it negative, what we are doing is reflecting over the x-axis. So at 1, we're going to be at negative 3. At 2, we're going to be at negative 9. And here is our, oops, we'll make it hit. Right there and there, no problem. Here is our p of x, a reflection over the x-axis. Next one we want to take a look at is the reflection over the y. So when we make our x negative, this is going to reflect over the y instead of the x. So it's still going to go through 0, 1, but this time at positive 1, it's 1/3. At positive 2, it's 1/9. At negative 1, we're going to have 3. And at negative 2, we are going to have 9. So this graph reflects across the y-axis. Z of x equals 1/2 times 3 to the x. So that takes our output values and multiplies them by 1/2, or cuts them in half. So instead of going through 0, 1, we're going through 0, 1/2. Instead of 1/3, it's 1/6. Instead of 1/9, it's 1/18. Instead of 3, it's 1.5. And instead of 9, it's 4.5. Over 1. I wonder that looked so funny. So again, a little tougher to see what's going on here with the exponential, just because of the tail part, how long it looks kind of flat, and then the growth part, or how fast it rises. So you really have to pay attention to the values that you are working with. So here's our second z to the x. We want this to grow twice as fast, so 2 times that 3 to the x. So we take our original 1, we multiply by 2, we get 2. We take our 1/3 and multiply by 2, we get 2/3 here at negative 1. When x is negative 2, we take that 1/9, multiply by 2, we get 2/9. At 1, when x is 3, we're going to multiply that by 2, and we get 6. And at 2, we can multiply 9 by 2, and we'll get 18, which I don't have that much room. So again, this is multiplied by 2. It's always going to fall above that parent curve. And then it's going to rise faster on the right-hand side. Okay, we now have another z to the x. I guess I got lazy about relabeling. We have 3 times x, 3 to the x minus 5. So whenever we make an adjustment to the x, we know that that moves us to the right 5 units. So my 0, 1 gets moved to 5, 1, 5 units to the right. My 1, 3 gets moved to 6, 3, 5 units to the right. I know that this is going to approach the x-axis on the left-hand side and then shoot up towards infinity on that right-hand side. Having trouble with straight lines. Notice that our asymptote, that y equals 0, stays the same. Let's take a look at our last one here. We have z to the x equals 3x minus 7. Which means the whole graph moves down 7, including the asymptote. So the first thing I'm going to do is move my asymptote down. My 0, 1 becomes 0, negative 6. My 1, 3 becomes 1, negative 4. I know that this is going to approach my asymptote on the left, shoot up towards infinity on my right. And there are our transformations.